Hello students, welcome to another session of online class. Today we are going to discuss a new topic called conditional joint probability or bivariate conditional probability, or the conditional probability for two variables. So as usual, our objective is to revise the topics related to this one, and for discrete as well as continuous cases, how to calculate the conditional joint probability, and conditional mean and variance for in the case of joint variables, and we will discuss some problems also. So moving into the revision, so our core idea is joint distribution. So we have probability mass function or probability distribution function for joint variable is given by fx of xy is equal to probability of x equal to x comma y equal to y. Here comma indicates that it is probability of being x and y equal to y, so that can be represented as intersection. So this was our core idea. So in the previous module we have studied that probability of A given B is given by probability of A intersection B divided by probability of B, that is the probability of common part for A and B divided by probability of B. If so, that can be extended for the probability distribution of univariate, which we studied in the last module, that fx of x, small fx of x given B is probability of x equal to x intersection B. So A intersection B is there. Similarly, x intersection B divided by probability of B, and capital fx of x given B will be probability of x less than or equal to x, because this is cumulative distribution, intersection B divided by probability of B. So we will today describe what is conditional joint probability mass function as well as density function also. So we know that fxy of x comma y given B, that is what we want. Similar to the previous one, fx, where fx of x comma b, x given B was there, here fxy of x comma y given B, because this is a joint distribution. Now that is nothing but, since x comma y means x equal to x intersection y equal to y, then given B means intersection B divided by probability of B. Now most of the case, since x and y are there, one depends on another, so most of the time the one of the variable will be the given condition. So we will assume that B is given as x is equal to x. So what is this fxy of x comma y given x equal to x is nothing but probability of x equal to x intersection y equal to y. This is the same part. Instead of B we have x equal to x divided by again probability of x equal to x. Now what is this? This as well as this both are same. So any one is sufficient, because intersection of A intersection A will be always A only. So that is why we have this expression reduces to probability of x equal to x intersection probability of y equal to probability of x equal to x intersection y equal to y divided by probability of x equal to x. Now what is this probability of x equal to x intersection y equal to y? Is nothing but fxy of xy, right? Joint probability distribution, x comma y. So fxy of x comma y divided by what is this? Actually fx of x. So this conditional distribution is generally represented like this. Given condition is x, so what we are measuring is probability of y given x as a probability of the values small y and small x. So we can generalize like this one: fy given x, y given x is equal to fxy joint divided by marginal. So here also this is in the case of density function or mass function. Mass function in the case of discrete and density function in the case of continuous. Similarly, distribution function, that is a cumulative distribution function, capital F, also can be derived in the same manner. That will give fx y given x will be fxy x comma y divided by x of x. Always remember what is the given condition that comes as the denominator. So we can similarly write fxy f of x given y of x given y is fxy of x comma y divided by fy of y. Joint distribution divided by marginal distribution. So before that, so that is what we have. We can generalize any conditional distribution of y given x as a joint distribution of x y divided by marginal distribution of x if it is given x. Now we have to remember all these equations we have studied in the beginning of this module, that is fx of xy will be conditional CDF. So we have to integrate up to x, minus infinity to x, minus infinity to y, fxy of alpha beta d alpha d beta, or xy dx dy. Fx of x means that is marginal distribution. This is joint distribution. This is marginal distribution. Marginal distribution is identified when you want x, you have to integrate only up to x. The other one will remain constant. That is for the entire length you have to do. Similarly, for fy of y is integrating up to minus infinity to y, taking d beta. Then this part will be completely added up. Whereas a small fx of x and small fy of y, that is a density function for marginal density functions, are obtained taking the entire function, joint function, and integrating up to minus infinity to infinity over. When you are taking x, you have to integrate over y. When you are taking y, you have to integrate over x. So this type of problems we have done. So this is in the case of continuous variable. For discrete, all the integrals will be represented in summation. So this is just to remember these equations so that this can be applied in our problems. Now, conditional mean and variance. The conditional mean for discrete variable is all represented as, the representation is also very important, mu of x given y. So mu x given y is expectation of x given y. So expectation of x is summation x fx of x, but fx of here it is x given y. So x into fx given y of x given y, and mu y given x will be similarly y into fy given x, x given y. This is in the case of discrete, and then for continuous it will change from summation to integral. That is the only difference we have when we. Similarly, variance sigma square x given y will be, sigma square x is expectation of x square minus mu x square. So here it is conditional. So sigma x square x given y will be e of x square given y minus mu x square y. Similarly, sigma square y given x is e of y square given x minus mu y square x. For discrete, to find this part x square, you have to integrate, summate over all the x values, x square fx given y of x given y, and for continuous it will be minus infinity to infinity integral over x. So here x is there, so you have to dx, you have to take. So this is about the theory part of conditional distribution. We will discuss a problem in detail so that you can understand how to do conditional distribution, joint distributions. So given a joint probability mass function, so this is a mass function, means that it will be discrete. Fxy is x comma y for x plus y equal to x plus y by 8 for x is equal to 1 and 2, and y takes the value 1, 2, 3. So discrete is obvious here, and find the condition 0 otherwise. Find the conditional probability mass functions, that is fx given y as well as fy given x we have to find. Calculate a probability of y equal to 2 given x equal to 1 and x equal to 1 given y equal to 3, and probability of find mu of y given x equal to 2 and variance of y given x equal to 2. So here 2 means it is obviously x equal to 2 is in these two cases. So we'll move to the first part of the question. So we have given fxy of xy is x plus y by 8. Now what we have to find is fy given x as well as fx given y. Both we have to find. So it is not explicitly mentioned, so we have to find both the cases. Now we have seen that the expression for y given x and x given y are, as I said, generalized expression. What is the generalized expression? Conditional probability is joint probability by marginal probability. So conditional y given x is joint of x comma y divided by, since this x given x is there, so marginal distribution of x. Similarly, this one is for the x given y. Now what we have to find, fxy of xy is already given in the question, so the denominator part is pending now. So what is fx of x? Fx of x, as I said, it is a marginal one, so we have to find the marginal from the fx of xy only. It is not explicitly given, so we have to find from this one only, taking y as the variable. So when you have to find x, you have to take y as the variable. So it is summation over y fx of x comma y, because what we want is a function of x. So if you add all the x's as 1 and 2, you won't get a constant here. So what you want, y as a variable, so that y takes 1, y takes 2, y takes 3, but x remains as such. So whatever you are getting is fx of x. Similarly, fy of y will be function of x comma y, summation taking x as the variable, so that y will not affect, so that the function will remain as a function of y itself. Now how to find fx of x? It is easy, right? For summation over fx of xy, so y takes the value starting from 1 to 3, so that is x plus y by 8, that will be x plus 1 by 8 plus x plus 2 by 8 plus substitute the values for y here starting from 1 to 3, so x plus 1 by 8, x plus 2 by 8, x plus 3 by 8. So that will be x plus x plus x, 3x, 1 plus 2 plus 3, 6, so 3x plus 6 by 8. That is a function of x. See here, it is just a function of x. You won't get a single value here, but a function of x. So this will be fy of y. So it should be added over x. So x takes the value 1 to 2. If you see the question, x takes the value 1 and 2. So x plus y, substitute x equal to 1, 1 plus y by 8 and 2 plus y by 8. So 1 plus 2 will be 3, y plus y will be 2y, the denominator is common, so divide by 8. So you got both the values, fx of x, fy of y, both you have got. So this you know, this is already given, here also this is already given, and this you calculated. Now our job is to calculate fy given x, that is fx of xy divided by fx of x. Remember, this equation has a conditional is equal to joint divided by marginal. So conditional joint is x plus y by 8, marginal is 3x plus 6 by 8. So 8 cancels here, these two 8's cancel, and you have x plus y divided by 3x plus 6. Similarly, you have like fx given y is fxy given, so given part is y, so fy of y. So something mistaken here, so this will be 3 plus 2y, 3 plus 2y divided by 8. So 8 and 8 cancel, so x plus y divided by 3 plus 2y. So you got two functions, y given x as well as x given y. Now we will go for the part B of the question. Calculate probability of y equal to 2, x equal to 1 and x equal to 1, y equal to 3. So probability of y equal to 2, x equal to 1 is a given conditional probability. So f y given x, so what is the value of y? 2 given 1. So we have the function x plus y by 3, x plus 6. There we have to substitute x is equal to 1 and y equal to 3. That's all. So you have 1 plus 2 divided by 3 into 1 plus 6, so 3 by 9 or 1 by 3. So we can calculate probability of x equal to 1, y equal to 3 also, right? fx given y is 1, so 1 given 3. 1 given 3, so x equal to 1, y equal to 3. You have to substitute in the function fx given y. So fx given y is nothing but x plus y divided by 3 plus 2y. So just to substitute that value here, so you will get 1 plus 3, 3 plus 6, that will be 4 by 9. So this is how we calculate give any given probability. Now the last part of the question is pending, that is finding the mu, that is y given 2 and sigma square for y given 2. So we have the general expression, mu y will be expectation of y, right? But mu y given x will be expectation of y given x, nothing but it is, if it is expectation of y only, it will be y fy of y, but here y given x is there, so y f y given x, x given, sorry, this should be y given x. So what we have to substitute is that in f y given, this should be y given x. So f y given x, where you have to substitute x is equal to 2, and summation is over all the y's, so y takes the value 1, 2, 3, so 1, 2 and 3. So y into f y given x is, we have calculated already, that is x plus y by 3x plus 6, right? X plus y by 3x plus 6, x plus y by 3x plus 6, y given x is given already. So that you substitute here and put x is equal to 2, so you will get 2 plus y divided by 3 into 2, that is 6 plus 6, 12. Now again you have to expand this summation, that is it is starting from 1 to 3, so put y equal to 1, 1 into 2 plus 1 divided by, this part is 12. Next y is 2, 2 into 2 plus, this is again 2 divided by 12, and y is equal to 3, 3 into 2 plus 3 by 12, that will be 26 by 12. Now moving into, this is mu y given x, that is that we have got, mean we can calculate. Now how to calculate the variance? So for finding the variance, we need expectation of y square minus expectation of y whole square, right? So expectation of y square given x can be calculated as, again there is a mistake, this should be y, I think I copied this one wrongly. So y given x is y given x, where x is equal to 2. So since it is expectation of y square, you have to substitute y square here. So function remains the same, 2 plus y divided by 12, y square will come, so 1, 2 square plus 3 square, substitute the value, so you will get 1 into 2 plus 1, 3, that is 3 plus 16 plus 5 into 9, 45, so you will get 80 by 12 or 20 by 3. So once this is got, this is not variance, so variance is nothing but expectation of y square given x minus expectation of y given x whole square, that is nothing but mu y given x whole square. So 20 by 3 minus 26 by 12 whole square, you will get 1.97. So this is in the case of a discrete random variable. So if it is asked for continuous random variable, what you have to do is you have to integrate wherever summation is there. So this is about conditional random, joint conditional random variable. So thank you.